Hello, am I audible? Hello,
Audible.
is my screen visible?
Yes.
Thank you. So, good afternoon, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Awan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So, in this live session, we will discuss some practice problems on this week's topics, which are bagging, boosting, naive Bayes and Bayesian network. These are the topics that are running this week. So I will discuss some practice problems on these topics, and after that I will also try to clear all your doubts and questions if you have any. So we can start. So this is the first question. A man is known to speak truth 2 out of 3 times. So this is a question related to probability and Bayes network and naive Bayes. So a man is known to speak truth 2 out of 3 times. He throws a die and reports that the number obtained is 4. Find the probability that the number obtained is actually 4. And there are 4 options. So you have to use Bayes theorem in this question. You can write your answers in the chat once you have computed it. Has anyone calculated it? So in this question, you have to first consider 2 statements as 2 random variables. First statement is that the man reports that the number obtained is 4. Let's consider this as A. This is statement A, or this represents the random variable A, that the man reports that the number obtained is 4, and another random variable B, that it is actually 4, and another variable the B, which is the number obtained is 4. So basically we have to find out probability of B given A, that the man has already reported that the number is 4, so A is given, and now we have to find out whether it is 4 or not. So probability of B given A, because A is given, it is already given that the man has reported the number to be 4. So based on that evidence A, we have to find out whether the number obtained is actually 4 or not, which represents statement B. So probability of B given A, this is the probability that we have to find out. So we can use Bayes theorem on this. So it would be probability of A given B into probability of B divided by probability of A given B, probability of B plus probability of A given B bar, probability of B bar. So what is probability of A given B? This part. So probability of A given B, that means the number obtained is 4 and the man has reported it to be 4. That means the person is telling the truth. So this is nothing but the probability of telling the speaking the truth. So which is 2 out of 3 times. So that means probability of A given B is nothing but that the probability that the person is speaking the truth. So which is 2 by 3. And probability of B is nothing but getting the obtaining 4 from the die. So which is 1 out of 6. Probability of getting 4 from the die is 1 out of 6. Similarly, we can find out A given B bar. This one, A given B bar is 4 is not obtained. B bar means something other than 4 has been obtained, but the person is reporting it is 4. A means he has reported it to be 4. So that means he is telling a lie. So that is the probability of telling a lie is 1 minus 2/3. So it is 1 minus 2/3, which is 1/3, 1 by 3. So this probability of A given B bar is nothing but probability of telling a lie. And similarly, probability of B bar we have to find out. This one, probability of B bar would be B bar means getting something other than 4 from the die. So it is 1 minus 1 by 6, which is 5 by 6. So now we can just plug these values into this Bayes theorem formula. We already know all these. We have calculated all the 4 terms that we require, and we can just put these values in this formula, and we will get this probability from this formula. So if we calculate it, it will be D 2 by 7. So this is how we can apply Bayes theorem for such problems. So answer would be D 2 by 7. So here I have written the detailed solution for this also. So we have to consider 2 statements as 2 random variables, A and B, and then we have to find out this probability. So yeah, so this is how you have to do it. Is there any questions or doubts in this? So this is the next question. This is on Bayesian network, sorry. So a graphical model for a Bayesian network is given, and you have to find out pair of random variables which are independent given no evidence. So from this Bayesian network, you have to find out the variables which are independent given no evidence, and 4 options are given: A, B, C, D, E, D, and C. So these are the 4 options given. So this Bayesian network basically represents relationships between different random variables. For example, variable C is dependent on A and B, so certainly C is not independent. Similarly, D is dependent on B, E is dependent on C. So this way the diagram or the Bayesian network represents relationships between different random variables. So from that point of view, you have to find out which pair of random variables are independent given no evidence. Basically, which of these variables are not dependent on any other variable.
Yeah, option
Option A comma B. So okay, any other answers? So here the answer would be A comma B. So from this Bayesian network you can already observe that C is dependent on A and B because there are two incoming arrows into C from A and B respectively, and same for D, it is dependent on B, and E is dependent on C. So A and B are the two variables which are not dependent on each other, because you can see there are no incoming arrows to it. So that means these variables are not dependent on any other random variable from this diagram. So answer would be A comma B, first option. So this one will be answer. So solution is that node A and B don't have any predecessor nodes, as they don't have any common parents. A and B are independent. So this is a question again on probability. Third question. Two cards are drawn at random from a deck of 52 cards without replacement. So two cards are drawn without replacement. We draw one card from it, and without replacing it back, we draw another card from the remaining cards. And what is the probability of drawing a 2 and an ace in that order? So what is the probability that we draw a 2 in first drawing and get an ace in the next drawing? Two cards are drawn at random from the deck of 52 cards without replacement. What is the probability of drawing a 2 and an ace in that order? So there are 4 2s present in the deck, and also 4 aces are present in the deck of 52 cards. So what will be this probability? Manvi Jain has written D, which is 4 by 663. Okay, so any other answers? Has anyone else computed? Vinod Govindan has also written D. So I've got 2 answers and both are saying D, 4 by 663. So there are 4 2s and there are also 4 aces present in the 52 card deck. So the probability we first first you have to draw a 2 and then we have to draw an ace. Someone else has unmuted his mic. Can you please mute it? Okay. So there are 4 2s and 4 aces. So first you have to draw a 2. So the probability of drawing a 2 from 52 cards is 4 divided by 52, because there are 4 2s present. So the probability of picking 1 2 is 4 by 52. And now as we have already picked one card, so there are 51 cards remaining in the deck. So we are doing this without replacement. So we are not putting the 2 that we have already drawn back into the deck. So we now have 51 cards remaining and we have to draw one ace, and there are again 4 aces. So probability of getting one ace is 4 by 51, because we have 51 cards remaining now. So 4 by 52 into 4 by 51, so it will be 1 by 13. So it will be 1 by 13 into 4 by 51, and if you multiply this, it will be 4 by 663. it should be D, 4 by 663. So this is how you can compute. So first you have to find out the probability of getting a 2 from 52 cuts, and then once you have picked the first cut, now probability of getting an S from the remaining 51 cuts. So that's why the second probability is 4 by 51, not 4 by 52, because we have already picked one cut in the first draw. So that's why it's 4 by 51, and first one was 4 by 52 because all the 52 cards were there. So we picked 1 2 from all the 52 cards. So 4 by 52 was the first probability, and second probability would be 4 by 51. So that way we calculate this probability of this thing. So D, 4 by 663 is the correct answer. So here I have written the overall process of doing this. You can use Bayes theorem also similarly, but without also using Bayes theorem you can do this. Now coming to question 4, this is again on probability and also related to Bayes theorem and naive Bayes. So a drug test which is represented by random variable t, so it can take positive or negative values because it's a drug test, has 1% false positives. That means 1% of those not taking drugs show positive in the test, and 5% false negatives. That means 5% of those taking drugs test negative. Now suppose 2% of those tested are taking drugs. So determine the probability that somebody who tested positive is actually taking drugs. So two random variables are there which are already mentioned in this question. Random variable t, which is the result of the drug test, and which can take positive or negative values, and the random variable d, which is whether the person is taking drugs or not, and t represents the result of the drug test. So determine the probability that somebody who tests positive is actually taking drugs. So you have to find out probability of t given d. You have to find out. You have to find out probability of d given t. So it is given that the test is positive. So given t, you have to find out the probability of d. So this problem can be a little difficult. You have to find out what these false positives and false negatives represents in terms of this random variables and the probability values in the Bayes theorem formula. Has anyone completed? So in this question, 1% false positive. So what does this represents in terms of probability and the random variables? So this is false positive means 1% of those not taking drugs show positive in the test. So this is probability of T given D, that not taking drugs, so D bar. So it the person is not taking drugs, so D bar, that's why. And the result is positive, the drug test returns positive, so probability of T given D bar, so this represents T given D bar. Similarly, the false 5% false negatives, so that means 5% of those taking drugs test negative, so means it is returning negative, so T bar given taking drugs. So sorry, it test negative in yes. So probability of T bar given D, that they are taking drugs, but the result of the drug test is negative, T bar given D. So probability of the first one, 1% false probability, that is probability of T given D bar is 1 by 100, and this 5% false negative, so it's 5 by 100. And from this we can switch this, probability of T given D would be 1 minus 5 by 100, so which is 95 by 100. So now and another statement was this, suppose 2% of those tested are taking drugs, so this is nothing but probability of D, that probability of taking the drug is 2%, so this is 2%, 2 by 100. So now we have to find out this thing from all these informations that we have got. So probability of D given T, we use Bayes theorem in it, probability of T given D into probability of D divided by probability of T given D, probability of D plus probability of T given D bar, probability of D bar. So we have already computed all these values. Probability of D bar, this is nothing but 1 minus probability of D, which was 2 by 100, so it will be 98 by 100. And all other values we have already calculated. Probability of T given D, first term, this is 95 by 100. Probability of D is 2 by 100, and also probability of T given D bar, this part we have already calculated here, 1 by 100. So we have calculated all the terms that we need for this probability, and we have to just put those values and we can calculate the probability. And if you put those values, the answer would be A, 0.66. So I have already written the formula and all the values here. So this is how you have to solve this question. Is there any questions or doubts on this? So now moving on to the question 5. So it is given that probability of A given B is 2 by 3, and probability of A given negation of B, this is negation, is same as probability of A given B bar, equals 1 by 4. So two probability values are given, probability of A given B and probability of A given B bar. Compute the value of probability of B given A. So you're given two probability values and you have to calculate this one, probability of B given A. So in this question you have to find out probability of B given A, which is probability of AB by probability of A. So you need to know probability of AB and probability of A, but the two probability values that are given, probability of A given B and probability of A given B bar. So from these two you will not be able to find out probability of A. So probability of A cannot be computed from these two probability values that are given. So because of that you will not be able to compute the value of this probability of B given A. So the answer here would be D, not enough information. So you need to know the value of probability of A, which you will not be able to find out from these two probability values that are given. So you will not be able to compute this probability which is required. So here answer would be D, not enough information.
Can I ask one doubt?
Yes.
Then what should have been given so that we could have found the probability of A?
So either probability of A wholly should have been given, or some other values, probability values would have been required, from which we would be able to find out probability of A. Either probability of A is already given in the question, but probability of A is not given, and also we will not be able to find out probability of A from these two probability values. So that's why probability of B given A can be represented as probability of, if we apply Bayes theorem, then it would be like this: given B, probability of B plus probability of A given B bar, probability of B bar. So A given B, this term is given here, but the probability of B is not given again, so we cannot compute. This probability is given, A given B bar, this is the second probability that is given, but this probability of B is not given, B bar is also not given, so that way also we cannot compute. So this way we will not be able to compute.
Okay, thank you.
So now question 6, this is on Bayesian network again. A patient goes to a doctor with symptoms S1, S2, S3, and the doctor suspects diseases D1 and D2 and constructs a Bayesian network for relation among the disease and the symptoms as the following. So the network is given, D1 and D2, these are the two diseases, and S1, S2, S3, these are the three symptoms, and there are some relations between the diseases and the symptoms. As you can see from this diagram, there are arrows given from some disease to some symptoms. So from that you have to find out the joint probability distribution in terms of conditional probabilities. So joint probability distribution means in this case, for this diagram you have to find out S1, S2, S3, D1, D2. So probability of S1, S2, S3, D1, D2, this joint probability distribution you have to compute in terms of conditional probabilities. So basically you have to represent this probability of S1, S2, S3, D1, D2, what would be this probability value out of these four options, and this can be easily observed from this diagram. The relations that are there, based on those relations we can find out easily. Dr. Preeti Jain says option A, and Manvi Jain says D. Any other answers? So the joint probability distribution P S1 S2 S3 D1 D2, to calculate this we have to first analyze the Bayesian network. So from the network you can see that D1 and D2, these two variables are independent of any other variables. So you just can write P1, P of D1 and P of D2. These are independent random variables. So these variables do not depend on any other variable. So P D1 into P of D2. And then for S1, S1 is dependent on D1. So for S1 we have to write probability of S1 given D1. And S2, symptom S2 is dependent on both the diseases D1 and D2. So that means probability of S2 given D1 comma D2. And S3, the symptom S3 is dependent on only one disease, which is D2. So it will be probability of S3 given D2. So this is how you have to find out the probability. You have to segregate all the terms and you have to analyze for each term what are the variables it is dependent on. So D1 and D2 is not dependent on any of the other variables, so you just write P of D1 and D2. For symptom S1, it is dependent on only D1, so probability of S1 given D1. And for symptom S2, it is dependent on both the diseases, so probability of S2 given D1 and D2. And for S3, it is dependent on D2 only, so probability of S3 given D2. So this way we have to find out which are the random variables each variable is dependent on, and based on that we have to write the probability values. So in this case D would be the correct answer. So this way we have to analyze the diagram and find out what are the relationships between any two variables, and based on that we have to write this probability values. So D is the right answer, and the explanation is given that from the figure we can see D1 and D2 are not dependent on any other variable, as they do not have any incoming direct edges, and S1 has an incoming edge from D1 and hence S1 depends on D1. S2 has two incoming edges from D1 and D2, so it is dependent on both D1 and D2, and S3 has only one incoming edge from D2, so it only depends on D2. So that way D would be the right answer. Is there any doubt in this question? Question 7. In a Bayesian network, a node with only outgoing edges represents for options are there. So a node has only outgoing edges and there are no incoming edges. So in that case, which of these following options is correct? Option A is a variable conditionally independent of other variables, B a variable dependent on its siblings, C a variable whose dependency is uncertain, and D none of the above. So the node has only outgoing edges, there are no incoming edges. Dr. Pritijan says A or B. Any other answers? So there are no outgoing edges, that means the node would look like this. There are only outgoing edges, so node would look like this. No incoming edge, that means such edges cannot be present. So only outgoing edges are present. So in Bayesian network, if these are the two random variables and this is an edge from B to A, so in this case a variable A is dependent on B. So from an edge is there from B to A, that means A is dependent on B. So if there are no incoming edges to a node, only outgoing edges are present, that means that node is not dependent on any other node. So from that point of view, it's a variable conditionally independent of other variables. So it is not dependent on any other variable. Only outgoing edges are present, that means other nodes are dependent on that node, but that node has no other dependency. So option A would be right, that a variable conditionally independent of other variables. So a variable is dependent on some other variable if there is some edge from that variable into the variable. So there are no incoming edges, that means it is not dependent on any other variable. So it is conditionally independent of other variables. So option A would be right. So this meeting is almost 1 hour. First hour is over, so I have to create a new meeting link, otherwise this meeting is going to automatically end in next 3-4 minutes. So I am creating a new meeting link and sharing the new meeting link in the chat for the next hour.
How many questions are remaining in this meet, in this session?
There are 4-5 more questions remaining. So Google Meet doesn't allow meetings for more than 1 hour. for normal accounts. So I cannot conduct one meeting for more than 1 hour, so I have to create a new meeting link.
Okay, sir. Just send the link on the chat box.
Yes, I'm sending, creating the meeting and sending it in the chat. So I have shared the meeting link. So first go to the new meeting and then end this meeting, or copy the meeting link and then end this meeting, otherwise you will lose this meeting's chat once this meeting is ended. So go to the new meeting link and end this meeting or leave this meeting, and I will join the new meeting in a few minutes once all of you have left this meeting and went to the new meeting. I can still see 3-4 persons in this meeting. Please join this new meeting that I have shared in the meetings chat, and I will join the new meeting in a few minutes once all of you have joined the new meeting. Am I audible?
Yes, sir.
Is my screen visible?
Yes. Yep.
Okay, thank you. So question 7 is done. So answer would be A. So as there is no incoming edge for the node is not conditionally dependent on any other node. So that's why option A would be the correct answer. Now question 8. This is on gradient boosting and AdaBoost. So which among gradient boosting and AdaBoost is less susceptible to outliers considering their respective loss functions? So both are boosting algorithms, gradient boosting and AdaBoost, and which of these two algorithms is less susceptible to outliers or noise points considering their loss functions? Dr. Priti Jain says B, gradient boosting. Anyone else? Does anyone have any other answers? Omkar Merchant says A, add a boost. So the correct answer here is gradient boosting. So you have to first know what are the loss functions these two algorithms use. Gradient uses squared error loss function, and AdaBoost uses exponential loss function. So as AdaBoost uses exponential loss function, it gives a lot of importance to the outlier points, but it is not required, because outlier points, we want to ignore those outlier points. But as AdaBoost uses exponential loss function, it gives a lot of loss values to the outlier points. So but gradient boosting uses squared loss, so it doesn't give as much importance to outliers as exponential loss would give. So because of that, a gradient boosting is generally uh, is more robust towards outlier points. So it would be B. So based on the loss functions you have to figure out. So the option answer would be B. Gradient boosting uses least squared loss function, while AdaBoost uses exponential loss function. So AdaBoost penalizes outliers to an exponential amount, whereas gradient boosting penalizes to a lesser extent. So thus cares less about them. So gradient boosting cares less about those outlier points because it uses squared loss function, but as AdaBoost uses exponential loss functions, it gives a lot of importance to the outlier points, which is not required. So that's why gradient boosting is less susceptible to outliers. It is much more robust towards those noise points. So now question 9, how do you prevent overfitting in random forest models? So there are 4 options. So option A is increasing tree depth, option B increasing the number of variables sampled at each split, C increasing the number of trees, D all of the above. So how to prevent the overfitting problem in random forest? Akanksha Joshi says B, which is increasing the number of variables sampled at each split. Anyone else? Any other answers? So here the answer would be C, increasing the number of trees. So why will it be increasing number of trees? So overfitting happens because of low bias and high variance. So if we use more trees in the random forest model, so more classifiers means the variance is reduced further. So if variance is reduced, we will be able to prevent overfitting. So overfitting happens because of high variance and low bias. And if we use more number of weak classifiers, in this case trees, the variance decreases. So once the variance decreases, we will be able to prevent overfitting. So because of that, the answer is C, increasing the number of trees. Is there any questions or doubts on this? So option C, increasing the number of trees, is the correct answer for question 9. Question 10, this is on ensemble methods. So ensembling in random forest classifier helps in achieving 4 options: reduction in bias error, reduction in variance error, reduction of data dimensions, none of the above. So how does it help ensembling in random forest model? Whether it reduces bias or variance or the data dimension, or none of the above? Dr. Preeti Jain says A, which is reduction of bias error. Anybody else? Any other answers? So any ensemble method generally reduces variance error, because we are using multiple classifiers to predict the same thing. So that reduces the variance in the error, variance in the prediction. So and even in case of random forest, the base classifiers are trees. So other than it is also an ensemble method. So ensembling in random forest classifier also reduces variance error. So the answer would be reduction in reduction of variance error. Option B, reduction of variance error. So any ensemble method is able to reduce the variance in comparison to single classifiers. Question 11, this is on AdaBoost algorithm. So considering the AdaBoost algorithm, which of the following statements is true? Is or are true, because multiple may be correct. So there are three options. A, in each stage we try to train classifier which makes accurate predictions on any subset of the data points where the subset size is at least half the size of the dataset. So this is on AdaBoost. Option B, in each stage we try to train a classifier which makes accurate predictions on a subset of data points where subset contains more of the data points which were misclassified in the earlier stage. And option C is the weight assigned to an individual classifier depends upon the weighted sum error of the misclassified points for the classifier. So which of these following options is or are correct? Multiple options might be correct. So does anyone have any answer here? Which of these options should be correct? The option A says that in each stage we try to train a classifier which makes accurate predictions on any subset of the data points. But in AdaBoost we know that not any subset we pick. We try to create a subset such that it contains more of the data points which were misclassified in the earlier stage. So which is exactly option B, that in each stage we try to train a classifier which makes accurate predictions on a subset of the data points, but the subset contains more of the data points which were misclassified in the earlier stage. So we try to create a subset which contains the points which were misclassified in the earlier stage. So we try to train our new classifier on those misclassified points so that it learns to predict those points better. So option B is correct here. Option A is not correct because we don't create any subset and train our classifier on this. We create a specific subset which contains more of the data points which were misclassified in the last stage. And option C says that the weight assigned to an individual classifier depends upon the weighted sum error of the misclassified points. So which is also correct because we compute the weights assigned to an individual classifier trained at a specific stage. The depends on the how accurate that classifier is, or the weighted error that it produces on the misclassified points. So we compute the weight in that way. So option C is also correct. So option B, option C, these two are the correct answers. Option A is a wrong option. So B and C, these are the two correct options. So B, C, these are the two correct answers here. So these were the questions that I wanted to discuss today. Is there any doubts or questions on the problems that I discussed, or any other doubts if you have related to the course content?
Thank you so much.
Thank you. Is there any doubts or questions? Is there any doubt? I can still see two persons in this meeting. If you have any doubts, you can ask. Otherwise, you may leave. If you have any doubt, you can stay in this meeting and ask me. Thank you everyone. I'm ending this meeting now.